Okay, we're making progress here. Thank you for your patience. Okay, so we're talking about quadratic equations today, which means we have equation form. I don't need that. AX squared plus BX plus C equals 0. And I'm sorry, I'm going to say an equation that could be written in the form. And A cannot be equal to 0. If A is equal to 0, what kind of an equation would we have? You check with your neighbor. If A is equal to 0, that means this term is wrong. What kind of equation would that become? Do you know the word? Starts with an L. Linear. Is linear. The quadratic versus linear. Okay. And zero product principle, also known as ZPP. Have we talked about ZPP in here? A little bit? Are you down with ZPP?
I'm down.
Thank you. The proper response is, yeah, you know me. Are you down with ZPP? Yeah, you know me. Okay.
Oh. Yeah.
Are you down with ZPP? Extra credit. Do you know that song? Do you know? Zero product principle or zero product property, as I normally refer to it, just says if you're multiplying two numbers together and it equals 0, we know something very specific about either one of these numbers. One of them must be 0, right? So if I'll write as an if then statement. If A times B equals 0, then A equals 0 or B equals 0. Do they both have to equal 0? No, just one of them. Could they both equal 0? They could. So when you see something like A, you say to yourself, hey, that's what kind of equation is that? Is it quadratic? There's a linear term, but there's also a quadratic term. And just like polynomials, we classify it by its highest term. So since there is a quadratic term, this is a quadratic equation. Now you notice in my definition, there were three terms. That C is just gone, right? C is just equal to 0. And that's fine, it's still quadratic. The important thing is it has x squared in there. And the way we're going to start solving this is by using ZPP, which means we need to make it a product. How do we make this left side a product? By factoring out the
2 on the end.
2 and the x. Leaving us with 2x minus 1. So I'm writing it in the form of something times something equals 0, which means we can use ZPP. So either 2x equals 0 or 2x minus 1 equals 0. And I think this is something you've seen before. Am I correct? I hope it's comfortable. Am I done with the problem? I'm kind of done, but I do have to find out what x is equal to. So for the left equation, I'll divide both sides by 2. So x equals 0, or on this side, nice, 2x equals 1, or x equals 1/2. Would you be comfortable going from there to there? As long as you're comfortable with it, that's fine. If you want to do a step by step, nothing wrong with that. Prefer you to be right than fast. For B, what kind of equation is it? Are you sure it's quadratic? Or is it linear?
No, it's ZPP.
It's CPP?
Minus.
But so when you look at it, you think, what kind of equation is it? You think it is a quadratic for sure. How do we know it's quadratic? That's that square there. Anytime you see that square, that two, it's quadratic, which means you're going to be using Z P P. So should I just divide both sides by 3x? No, that's not using ZPP. And for ZPP, the most essential ingredient is the zero. I need a zero, so I'm going to subtract that 9x from both sides. I could subtract the 3x squared from both sides, but it's nice to have that leading coefficient positive. So I'm going to keep it right where it is. 3x squared minus 9x equals 0. I'll let you finish. I'll call him one lucky individual. Just about 15 seconds. Make sure you're keeping up. You check with the neighbor just to make sure they're not completely lost. And Ethan, just so don't forget about Upton before behind you. Okay, Upton, can you help me with this one, please?
Yeah.
Thank you. Good morning.
Those 3x. You like to pull out 3x and x minus 3 equals 0. Yeah. So and then we go. Wait.
Yeah.
Yeah, your 3x equals 0 and x minus 3 is 0. And then there she's x equals 0 or x is 0.
Nice. Thank you. I normally leave the or out of there, but you could keep it or not. I'm not going to grade based on if there's an or. But it becomes we're going from here to here. Up to you. It's fine if you do. Just please do not go from here to here. Upton, thank you for your help. Okay. For D, step one. Well, I'm going to give you a chance to do that. I think you could do all of these. Both of these, D and you have this. You have the knowledge. E may be easier than D, isn't it? Yeah, I'm trouble with D. Maybe type E first and then go on to D. We just go over this together? That'd be helpful.
Yeah, we should.
I'm gonna go over E first. Should I subtract 9 from both sides? That would be a really good strategy if we're dealing with a linear equation. Or for quadratic, we want to use what strategy? The 3 letters are ZPP. So when you see that 0, you keep it. So what do I have to do next? Factor it. Do you know how to factor that left side? I think so. You're thinking what two numbers multiplied in 9 and add to -10. I think that answer is -1, 9 and -1. Yes. Now we're perfectly set up for ZPP. So x minus 9 equals 0, x minus 1 equals 0, x equals 9, and or x equals. Should we check? You're gonna live on the edge like that? It just seemed right, right? Everything was it worked out so beautifully. It's got to be right. But let's at least check the 1. Does 1 work? See, 1 plus 9 minus 10, 0. Let's do 9. 81 plus 9, 90 minus 90. It's good stuff. Do you think there are other answers to this problem? No, that's it. Just 2 answers. We found them quite easily thanks to ZPP. Yay. So for this one, 2x squared plus x minus 1. Is that how you started? Now, if you're having trouble factoring these, what you need to do is say these words in my office or on an email. Mr. Lieberman, I'm having trouble with factoring. Can you help me? Oh, it's not factoring? Oh, how do we do this problem? Oh, from here though. You're right. Getting to this was not a problem, but moving on from here, we have to factor so we can use ZPP. Man, did anyone factor that? I'm on D though.
Oh, x equals 0,
I want to factor this.
2x minus 1 x plus
Is this true? 2x minus 1 and x plus 1, you said?
Sure.
Okay, so one method is to believe Ben. It's not a reliable method. You can't use it during a test or at home. Any questions? No, I'm sorry.
Why can't it be 0 now? Oh, because it would be wrong.
Because it would be wrong. Yeah. Any questions? Okay, let's see what we could do with F, G, and H. I'm going to call on 3 people to help out with these.
This is all this energy. It's the opposite. So. That was the negative 7 that makes sense for you guys. Yes. So people are having a hard time getting through F.
But the first step is pretty easy, isn't it? Do you agree with that? First step is easy because all we have to do is set it equal to 0. I'm going to use those words, set it equal to 0. Does that make sense? Because I'm going to move everything on the left side or the right side. Okay. So I'm going to use this method. What number goes on the top? Positive or negative? Negative 60. What number goes on the bottom? So now I have to find two numbers that multiply to negative 16 adds to negative 7, negative 12, 5, if it works. Thank you for doing that work for us. Now, there's going to be times when you just can't find it. When that happens, I want you to just on the side, I'll do it on the action, like the side of the paper here. Take this and just make my factor pairs. That's obviously not going to work. I'm just going to look for something that could somehow give me a combination of negative 7. 4 and 15, right? There's no way, right? One of them has to be positive, one of them has to be negative. Then we see when we get here, 5 and 12. There it is. You'll get there eventually if one exists. Okay, so we have that negative 12 and 5. You remember what to do with those two? Because if you just put them in parentheses, now you've gone about it incorrectly. We're going to take that middle term and what do I do with these two numbers? Do you remember? Yeah. Yeah, 3x squared minus x minus 20. You break up that middle term. So these two. And now we factor. What are the next two words? Factor by grouping. Yeah, grouping. Factor by grouping. And hopefully it works out. 3x leaves us with x minus 4 plus 5. X minus, oh, look at how nice that is. I forgot my equals 0. Bless you. Sometimes I sneeze when I get excited about math too.
Me for too good at stutters on that.
That's what I do when I do. So here it is. Texas movie verb. Joseph, can you help me finish this problem, please? That F? Yeah.
Um, so then you love 3x plus 5. Oh, well, you could like also root the x minus 4.
Thank you.
Then 3x plus 5 0, and 4x minus 4 equals 0. And then x, oh, well, 3x equals negative 5, divide both sides by 3, x equals negative 5 over 3, and then x equals.
Thank you. Are you okay with this, everybody? For help there. I'll call on someone for G and H in just a minute or so.
it just needs to know between. Should be so that.
You should be. I didn't.
Be calling someone just a little bit for G and H.
Doing this one. I was just doing. H was your fault. Why did I become? So now I'm G score. So.
10 seconds. You've already discussed G and H with your partner, right? You sure it's okay? Okay, ready or not? Let's see what you got. Mia Rose, can you help me with G, please? One moment, please. Sorry, I'm gonna ask you to just listen to Mia Rose for now.
First subtract 20.
Okay,
And then you should change that to 4x squared minus 9.
first squared minus 10x, you said? Plus 25? And why did you choose -10 and -10? Are we good with that? Yeah, once you fill that out correctly, then when this is not 1, you must break up that middle term if you're using this method. I'm sorry to interrupt. Okay.
And then you can just do 2x minus.
Oh, interesting. Okay, yeah, it's perfect. Any questions?
You have to do this for that.
No. It can be 2x minus 5 times 2x minus 5. But I urge you, if you have 2x minus 5 times 2x minus 5, don't write this twice. Once you have one, it's already done. Miros, that was fantastic. Thank you.
And the 7 can you just stop there?
Absolutely. Yeah. I do want you to notice that if you start with an equation, you are going to end with an equation. And I want an equal sign in every line, please. Okay, next. H. Inaris, could you help me with this one, please? Oh,
Okay, so first you like are gonna bring it in and you'll get 8. And then
wait, do I have to do something with that 4?
you have to like
Oh, okay,
square.
okay.
And then you can break that into 2x squared plus 8x and then minus 1x minus 4 equals 0.
Okay,
I got that by multiplying the negative 1 to 8. And
like it.
then you can pull out a 2x and then you'll get x plus 4 and you can pull out negative 1 you get x plus 4 equals 0. And then you break up the equation, you have 2x minus 1 equals 0, which equals x equals 1/2. And then you have x plus 4 equals 0, and that'll get you x equals negative 1.
So x equals 1/2 and x equals -4. Is that correct? Do we agree? Are there any questions? Inaris, thank you. That's fantastic. By the way, if you get something like this, and this will happen sometimes, if you're trying to factor by grouping and you see something like this, then you need to what? Stop, go back and figure out your mistake because you can't continue if those two mini parentheses don't match. You cannot factor them out if they don't match. So the fact that these are both +4 should give you a little bit of happiness and say, ah, proceed. Any questions? Let's finish this up. If I tell you x squared equals 9, do you already know the answer to this? So please check to see if your neighbor knows the answer. If x squared equals 9. Can you please show me your solution? Right, you need 2 hands for this, don't you? Or right, you need the 3 and the -3. And you got that by doing what? So you didn't use ZPP? Why not?
Not what I choose to do.
Not what you chose to do. But what kind of equation is this? There's no such thing as equal. What kind of equation is this? That's a quadratic equation. We know that because it's x squared. So we could say x squared minus 9 equals 0. Then we notice that x minus 9 is a difference of squares. So we know how to factor that, don't we? I hope we get x plus 3 and x minus 3 equals 0. And then from there we get x equals plus or minus 3. But that's way too much work, isn't it? Because like you suspected, we could just take the square root of both sides. We could just say that x is equal to plus or minus 3. And that's something you could always do when that x is being squared. So the square root property, if x squared is equal to a, then x is equal to plus or minus the square root of a. So you can use that anytime you have that variable being squared. So for example 2 part A, let's isolate the square. 3x squared equals 15. X squared equals 5. Is this even doable? I can't solve for x. It's not going to be pretty. It'll be okay, though. From here, we know that x is equal to plus or minus square root of 5, which is not a clean answer, but it's an answer. For B, I'll give you a chance to finish this on your own. You're welcome. Luke knows EPP, okay? Are you sorry for things in the future?
No, yeah.
Okay.
Yeah,
Okay. Yeah. Check it with your neighbor. Is this even possible? Can we use imaginary numbers? Well, have we studied imaginary numbers?
Yes.
Then use them. Only if it's appropriate. Only if it's appropriate.
5i. Yeah. Well,
So who'd like to help us with this one? Ben,
Could be wrong, but I did 9x² equals -25.
I appreciate the disclaimer, by the way.
And I divided each of them by 9, so I got x² equals -25/9. And then I square rooted it, so I got -25. So rad -25 over rad 9, which equals 5i/3.
Like this?
Yeah.
Okay, so that equals 5i/3. Do we agree? Nice. Any,
Because it's I, there's no equal plus pretty much.
oh, who taught you that?
But we won't need a plus minus rules because it's, right, it wouldn't be plus minus 5i, would it?
I don't know, would it?
I don't think he's pretty great.
Yeah, because
I'm really like to cut.
Well, let's make an easier one. Let's make it just, let's say that x², I'm gonna make a little box here for it, like a little playground. Let's just make it x² equals -1. Now this is kind of the same thing, but much simpler, isn't it? So could I make this x equals plus or minus square root of -1, or x equals plus or minus I? Would that be appropriate?
minus I on this.
Let's check. What is I squared? It's -1, isn't it?
Yeah.
How about -I squared? What voice was that?
Negative I switches to 20.
-I squared is the same thing as I squared, isn't it? -I times -I is going to be I squared, which is also equal to -1. So even when we're dealing with imaginary numbers, there are two, it's going to be plus or minus I, which is a little bit weird. Yeah, so that's why I left a little bit of a space there. I'm going to adjust this because that square root property says we're always going to have two, the plus or minus. Although I appreciate the thoughtfulness of thinking that maybe this is a different case, but it's not. For C, what should we do first? You might be tempted to like say, I know what x minus 2 squared is, but we're not going to do that. The gesture I want to see for this, when I ask what do we do first, the gesture I want to see is, ready? Boom, boom, boom. See what I just did? Boom, boom, boom. What's that? Yeah, take the square root of both sides immediately. That leaves us with, on the left, x minus 2, and on the right, just positive square root of 6, plus or minus square root of 6. And now it's going to be x equals, oh, you remember 2 plus or minus root 6. I'm going to squeeze that in before the plus or minus. 2 plus or minus square root of 6. I'll give you a minute to do D, E, and F. I will be calling on 3 amazing young people. And then we'll have time.
We have to also square root 11.
Whatever you do to one side, you have to do to the other. Make sure that the square is isolated first. Like here, it was isolated, wasn't it?
Mhm.
Right here, the square was isolated. Yeah, so make sure that for D, your partner is doing the right first step.
You don't.
For D, make sure the first step is correct, because otherwise, all is lost. I'm about to call someone to just tell me the first step for D. Just the first step. Dan, what should I do first for D? Are we good with that? We move that 11 over? Perfect. So we get all that equals negative 11. Okay. Be careful, there's something you have to do F2 before you do the whole square root. Check it with your neighbor.
So you don't.
E and F are really kind.
Are they kind? Oh, they are. Yeah, I don't know why E and F was after D.
I don't know, but I love.
Yeah. Yeah. I agree with you. They might show up. Someone's singing. Joseph, is that you? No, that's not me. What? I'm just kidding, Joseph. That's obviously not you. That's obviously Luke. You have a lovely voice.
Yeah. It's just negative five. Negative five.
Are we ready? Dan, I'm going to give you a first choice. Do you want to continue, D, or should I call someone else? I think you could finish it. Are you comfortable with that? Okay, what do we do next? Always, yeah. Plus or minus square root negative 11. Cool. Oh, I did 111 accidentally. I got a little excited. Okay. And then it's what, minus 5 after that? Is that what you did?
Say, negative
Oh,
five.
wait, just a minute. Are you finished?
Yeah, James.
Okay. How about the square root of negative though? Could we take anything out of that? Yeah, so square root of negative 11 is the same thing as saying I root 11. So I'm going to replace that square root of negative 11 with I root 11 like that, if that's okay.
No.
Now this answer is correct. But I do want to change the form by, yeah, I would like that negative 5 first. X equals negative 5 plus or minus I root 11.
So I can do after, just not in,
Yeah, yeah. Yeah, you could do square root 11I.
It's like risky.
It's risky because if you do this,
I feel like you just want to do.
yeah, yeah. Why play with your grade like that? Dan, thank you. That was great. James, can you help me with E, please?
Square rooted both sides
Okay.
to get. What's 13? Let me just do 5.
Why would it just be 5? let's see, square root property. If x squared equals something, when you take the square root, it's always going to be plus or minus. Right, so you're like a robot that way. You don't even have to think, is this a special case? We'll say plus or minus 5. Okay. Do you mind if I squeeze that right there before the plus or minus?
So I guess you get two answers.
Yeah, we should.
I got x equals -8. And then it could also be x equals -18.
Any questions? And I just want to show you, James, that was great. Thank you. I hope that makes sense. It's easier to do it like this, to have -13 plus 5 and -5, if you think about a number line. -13 plus 5 and -5, rather than starting with -5 and then adding, or starting with the -5, starting with the +5 and then subtracting 13. Last one. F. Tess, help us with F, please.
So I divided by 2 first, so I got 3x minus 2 squared equals 16.
Why is it important to divide by 2 first? Nice, perfect.
And then I got 3x minus 2, and then I did square root, and I got 3x minus 2 equals plus or minus 4. And then I split them into 2 separate equations. And then I got 3x minus 2 equals 4 for one
Okay.
equation, and then 3x minus 2 equals -4 for the other equation.
I like it. Okay,
Then for the 3x minus 2 equals 4 equation, I got x equals 2. And then for the other equation, I got x equals -2 over 3.
any questions? Do you like solving by square roots? We need to hit 0 for ZPP. But for square roots, we do not need it. We need to isolate the square root, or the perfect square, and then take the square root of both sides. Now, I do want you to notice, where is the radical? It's in your brain. I don't need, like, when we're doing this as a gesture, that's in our mind, take the square root of both sides. We do see it. Like here, like, again, I'm not gonna put a square root on top of this. You know why I'm not gonna put one here? And listen up, guys, just one more minute. Why am I not gonna put one here at this x squared? Because I'm likely to forget that plus minus. So I just put it over here with that plus minus, and then you see that square root of -11, etc., etc. Nicely done today. You can zone out for a little bit and then start the homework, or just start the homework.